Well, we are on the last section of rationals. So, section 5, we're actually going to break up into two parts. Today's video is going to be on solving rational equations, and then tomorrow's video will be on solving rational inequalities. So, by the time you are done with today's video, your goal is that you want to be able to solve a rational equation by multiplying by the least common multiple, aka common denominator. So, first example, we've got x plus 8 over x equal to 6. And there are absolutely different ways to solve this. Now, the way that I'm going to recommend is that we basically try to remove the fractions out of the problem to solve it. I've found over the years that that is generally the most well understood method of doing these. So the way we're going to do this is we're going to look at all three terms, because the x, the 8 over x, and the 6 are all individual terms. And only one of them shows a fraction. You know, technically x is over 1 and 6 is over 1. So they're all fractions. So finding the least common multiple, or the common denominator, is actually awfully easy just because there's only one fraction in this one. But this is the exact same process we used in the last couple sections, like especially when we added and subtracted fractions. So the least common multiple, or common denominator, of this entire problem is x. So once you figure out the least common multiple, you're going to multiply every single term by the least common multiple. Okay? Once you do that, the goal is that whichever problems have fractions, the least common multiple will automatically cancel off every fraction. This x on the bottom cancels with this x on top, and they both leave a 1, they reduce, but you know that's not going to show up anymore. So then next line, this x times the x that was there would give you x squared, and then now I have a 1 times 8, and then that's going to equal x times 6. And I no longer have fractions. I have a quadratic equation because it's squared. And since I'm trying to solve a quadratic equation, I have to make it equal to 0. So I'm going to subtract 6x to both sides. And when I do that, I have x squared. I'll write everything in the correct order so it's easier to identify. But I have it equal to 0. And when you have a quadratic equal to 0, you can solve it multiple ways. The quickest usually is factoring, if you can factor. If you can't factor, most people do quadratic formula, but this one does factor. So this one factors into x minus 4 times x minus 2. And once you have factors equal to 0, you're going to take each factor and set it equal to 0. Now, what I haven't mentioned yet, earlier this chapter, repeatedly we've talked about domain restrictions. This is where domain restrictions come in. If I go look at my original problem, I only had one fraction, but that one fraction had a domain restriction, where if I took the denominator equal to 0, that was my domain restriction. So basically, I wasn't allowed to have x have an answer of 0. Now it worked out okay because the two answers I got were 4 and 2. Neither one of these answers was 0. If for some reason one of our answers was x equals 0, we would have to cross it off because it wouldn't technically work. Because if we would take these numbers and check them back in the original problem, you'd get divided by 0. So this is mainly what domain restrictions are going to be for, is for finding solutions and knowing which answers can't be actual answers even though they look like it. So this one we got two answers. Why don't you guys try a problem on your own, see if you can find the answers, look at any domain restrictions to see if something should be taken out or crossed off, why don't you pause it on this spot, go through the work of solving it. Okay, now that you're done, you should have gotten a least common, this is a brain fart. Least common, least common multiple is 4x. And when I multiplied everything by 4x, every single fraction and denominator canceled off. And you were left with an equation. The equation is not always going to be quadratic. The first one was, this one wasn't. So this one wasn't quadratic, so all I did was get the x's and the numbers on separate sides, and then I ended up getting x equals 12. And if I would have looked back at my original problem, this fraction had a factor of x. This fraction had a factor of 4. So I would have set all of my factors equal to 0 to look for domain restrictions. Now, this doesn't give you any information at all. But x equals 0 would have been a domain restriction, which would have said x can't be 0 as a possible answer. And the answers I got were not 0, so that works out okay. So x equals 12 ends up being my answer, and it's not one of the restricted answers. Okay, let's move on. Let's try a little bit harder one. So we've got 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. Well, we've got different denominators all over the place. So what I need to do first is figure out my least common multiple, or my common denominator. My common denominator, I've got two different factors. I've got an x minus 7 and I've got a 2. So basically my least common multiple is going to be those two factors, because I could multiply everything by one or the other to make it into 2 times x minus 7. So instead of getting a common denominator, which is a method if you want to do it that way, the method we're trying is that we are purposely multiplying by the common denominator or least common multiple, and we multiply every term, so plus and minus signs and equal signs separate terms. We're multiplying every term by 2 times x minus 7. And then we specifically are doing that because then that would purposely cancel every single fraction. And it should cancel them perfectly. Now there are things left on the top, and that's okay. Like this first fraction has a 2 times 2x minus 9. So 2 times 2x minus 9, you know what, I'll actually just write that. I was just going to do it in my head, but I'll write that out. 2 times 2x minus 9. And then I've got an x minus 7, and an x, and then a 2 and a 5. So I'll simplify this down. So I've got 4x minus 18 plus x squared minus 7x. Suppose I should do that. Equals 10. And then this is quadratic, so I will put everything on one side of the equation. So I have x squared. What do I have? I have 4x minus 7x. They're on the same side, so I just put them together. Minus 3x. I've got minus 18, and then I've got to subtract 10 to bring it over, so then that would give me minus 28 equal to 0. I factor it if I can, and this one I can because I've got 7 and 4. So minus 7 plus 4. And I'm going to solve each factor individually. And I end up getting 7 and negative 4. And then now I need to check if either one of those answers has to be thrown out. And I look at the factor of my first fraction. Factor of my first fraction was x minus 7, and I actually find out that in one of my domain restrictions is 7. My other fraction has 2. Well, 2 equals 0, it doesn't find me anything. But one domain restriction is 7, which I got as an answer. So what happens is I have to throw out that one answer that I found. And x equals -4 is going to be my only answer that works. And that's how you have to make sure to use domain restrictions. Okay, try one on your own, which I believe has a domain restriction as well. So pause it here, work it out. Okay, if you worked it out, if you multiplied by the least common multiple, you got a quadratic again, which factors, which they're not always going to factor, but in this section they probably are because we need normal numbers to try to practice this. So we ended up getting -6 and 1 as our possible answers. Well, 1 was one of the domain restrictions because of the very first fraction. So I had to throw out 1. And you can see down below in blue I wrote them, excuse me. Instead of looking for domain restrictions, I basically took the answers and plugged them back in to test them. And you are welcome to plug them back in and test them. It's kind of the exact same thing. But other than that, I mean, like we could look for domain restrictions like we had been doing. And whichever way kind of works for you, do that. 6 equals 0 doesn't find you anything, but this one does find a restriction at 1. So we threw a 1. Any which method works. Okay, way to go. One video left.